Hi and welcome to tutorial on SQL Server, customizing the database design. The power of DBMS lies in the control that it offers the user over data lying underneath. A programmer can optimize the efficiency of system-specific implementation by customizing the structure of data. The basic customization features are adding a primary key, adding a foreign key, adding constraints, unique constraint, not null constraint, and check constraint. So how do we manage the data integrity? Data integrity consists of SQL Server 2008 helps us to guarantee the accuracy, validity and correctness of the data stored. We have a set of rules which are to be followed and defined by the programmers so as to decide if a given data is valid. So what is a primary key? A primary key can be defined as a field or an attribute in a table which is used to uniquely identify a record. For example, consider this dream database and try to identify a key which uniquely defines every record. By careful observation, we can see that the dream number here uniquely defines every record, hence dream number in the dream database is called the primary key. Suppose we have more than one field for a primary key, then the decision of choosing among them lies with the database designer. So how do we add a primary key? Every table must have only one primary key. The primary key must be defined during the creation of tables. The syntax to create a primary key is create table, table name, and the field name, field type followed by a primary key keyword. For example, consider the dream table database. In order to create a primary key dream number, here we use the syntax create table, dream number followed by its type int followed by the keyword primary key. Now let's take a step back and redefine the primary key we have learned till now. The definition that we have learned till now said that the primary key is a field which lets us to uniquely identify a record in a table. In real-world cases, a single field may not be enough to identify a record in a table. In such cases, we form a collection of two or more of fields in order to form the primary key. For example, consider this hospital patient table. In this case, it would be possible to create a primary key which could be a collection of three fields such as patient ID, date of admission and time of admission. The SQL command to do this is create table, table name followed by fields, specify a constraint along with constraint name followed by primary key and followed by the group of the field names you want to combine. In this patient table database, use the query create table patients followed by the field, specify the constraint as constraint, patient P keys, primary key of three sub-data fields such as patient ID, date of admission and time of admission. So how do we add primary keys to an existing table? The SQL Server allows primary keys to be added to an existing table using the syntax for alter table, specify the constraint or add constraint followed by the constraint name and primary key. For example, consider the patient database. The command to define the primary key after creating the table is alter table patients, add constraint followed by name of the constraint, primary key and specify the fields to be taken as primary key. Let's understand foreign keys. A foreign key is nothing but a field or attribute in one table which is used as a primary key in the other table. Consider two tables, dream table and its reference being luck table. In dream table, we have dream number as a primary key. And we can see that in luck table, we use the primary key of dream table, that is dream number. So it becomes a foreign key in luck table. Remember that foreign key entries can repeat but not primary key entries. And every foreign key value must be present as a primary key in the reference table. For example, in luck table, if we try to insert a dream number of 3, it shows an error because there is no such dream number 3 in the primary key field of dream table. In SQL Server, a foreign key can be created using the syntax create table followed by table name, specify the fields and specify foreign key references followed by table 1 name and table 1 field name. In the example before, we create the foreign key using the syntax create table, luck table, dream number, its data type, foreign key references, dream of dream number and followed by the other fields. Remember that it's essential to create the table which is being referenced by foreign key before creating the foreign key itself. So how do we add foreign keys to an existing table? In SQL Server, we do this using the syntax alt table followed by table name, constraint add foreign key followed by field name, references followed by the reference table name and its field. Consider this example. Say we have table A and table B, and table B has an attribute B1. B1 references to primary key A1 of table A. Now we want to use a command to add B1 as foreign key of B. It can be done using the command alter table B add foreign key of B1 references A of A1. Let's understand not null constraint. While feeding data into database, sometimes the value of a particular field becomes highly valuable for data processing. In such cases, we have to prevent a null from being assigned to that value. In order to do that, we use null. For example, in this customer table, the name of the customer becomes very important. So, it cannot be made null at any time. In order to do that, use the not null constraint as create table customer, specify the field, and name varchar of 10 followed by the constraint not null. Remember that an attempt to insert a null value into not null field will be flagged as an error. Let's understand unique key constraint now. Primary keys are inherently unique by nature. In SQL Server, it's possible to designate any other field to be unique. The field here, which is designated as unique, will not accept duplicate values. Consider the customer table. Here we have customer ID as the primary key. In order to make customer card number of the customers as unique, we use the syntax create table customer followed by the fields credit card number and specify the constraint unique. Remember that an attempt to insert a credit card number that already exists in table now will be flagged as an error. Okay. Now let's understand check constraint. A check constraint is used to specify some rules for the data that can be stored for a field. A check constraint can be defined while creating a table or can be added to an existing table. While adding a check constraint to an existing table, the data that the table holds is checked against the constraint being defined. The no check command is used to prevent this checking. Check constraint can be defined on a single column or across multiple columns of the same table. Go through the SQL syntax here. We have create table, table name, field name followed by check constraint and check constraint. The check constraint may be such as field name greater than 1000, a field name between 1 and 100, which specifies a field name can take values between 1 to 100, say 2, 1, 2, 3, 99, 100. Field name like 0 to 9, 0 to 9, A to Z, capital A to Z, which denotes that the field name can be a single value in the range specified. It's possible to add check constraint to an existing table using the alter table command. The syntax for this is alter table followed by table name, specify the constraint add check, field name followed by the condition. For example, alter table student add check see GPA between 0 to 10. This checks for the constraint for the student whose GPA lies in between 0 to 10. Complete the tutorial. In this tutorial, we've understood the concepts on how to manage data integrity, primary keys, their definition, how to add primary keys while creating tables, how to add primary keys to an existing table, how to create multiple field primary keys. We've understood the concept of foreign keys, their definition, adding foreign key while creating table to an existing table. We've understood the concepts of not null constraint, unique constraint and check constraint. Thank you.